Question 6. The circle C has centre A with coordinates 7, 5. So this here, A is 7, 5. The line L with equation y equals 2x plus 1, so that line there says y equals 2x plus 1, is the tangent to C at P. Okay, so that makes sense. That's the tangent. So part A, show that the equation of the line PA is 2y plus x equals 17. So we're trying to find the line PA, and because it's through the center to the tangent, we know that's going to be right angle, so that's going to be helpful to us. In part B, we need to find an equation for C, so we need to find the equation of that circle, and then the line with equation y equals 2x plus k is also a tangent. Find the value of k. So I guess you can see that it has a gradient of 2. We're going to try and find this line that's the tangent on the other side of the circle. So we're trying to find the equation of PA. So we know it's a straight line through PA. We know it's perpendicular to L. So the gradient of L is 2. Y equals mx plus c. This is our gradient. So this implies that the gradient of the perpendicular line, so the gradient of PA, would be the negative reciprocal of 2, which is negative a half. We also know that the point 7, 5 lies on our line. So the equation to find straight lines, y subtract y1 is equal to m multiplied by x subtract x1. And so we know the gradient and we know the points that we're using. Putting all of our information into this formula, we're going to get y subtract 5 is equal to negative a half multiplied by x subtract 7. I'm going to times everything by negative 2. So that will give us negative 2y plus 10, and that cancelled out this negative half, so we get x subtract 7. So if we add that 2y, so it's over with the x, and then we add 7 to the 10, so the opposite of negative 7 is plus 7, we end up with 2y plus x is equal to 17, which is what we were trying to show for 3 marks. In part B, it wants us to find the equation for our circle. So let's remind ourselves, so the general format of a circle is x subtract a squared plus y subtract b squared is equal to r squared, and this has a center AB and a radius is r. Now we know the center, but we don't know the radius, so that's what we need to find out. So how could we find the radius? Do we actually know what P is? Do we know this point? Because if we did, then we could find the radius that way. How could we potentially find P? So we know a line that goes through P here, and we also know that PA also runs through that. So we could do simultaneous equations and we can find out what P is. So doing simultaneous equations with y equals 2x plus 1 and 2y plus x equals 17. Now because y is a subject, what we could actually do is do a substitution, put that straight in there. So that implies that we get 2 lots of 2x plus 1 plus x is equal to 17. So that would be 4x plus 2 plus x equals 17. So to take the 2 over, add the x's, you get 5x is equal to 15. Some nice numbers. So x is equal to 3. And that means that if you sub x into y equals 2x plus 1, we get y equals 7. So we've just found P. P is 3, 7. So we've now found P, which is 3, 7. And we already knew A was 7, 5. So if we can find the distance between these two coordinates, we will have found our radius. And there's a couple ways to do that. So there's a distance between 2 points formula. So the distance is big square root, so the difference between your x values squared plus the difference between your y values squared. So that formula effectively comes from Pythagoras' theorem. The other way that you can do this is if we draw a little right angled triangle and we can look at the distances. So I'm going to do both methods at once and you can kind of see where the formula comes from. Using the formula, so the radius will be the square root. So the difference between the x's, so it would be 7 subtract 3 squared. Now 7 subtract 3 is the distance between the x values. So that's 4 on the bottom there. And then what we're going to do is y2, so 5 take away 7, which is negative 2 squared. Now 5 take away 7 or 7 take away 5 means that this height is 2. In this right angle triangle we've created, we can see that r is going to be the square root of 4 squared plus 2 squared. In this formula, we're going to get r is equal to the square root of 4 squared plus negative 2 squared is just the same as 2 squared. So we're going to get r is the square root of 16 plus 4, so the square root of 20, or you could say r is equal to 2 root 5. Now that we know r, and we also know the centre of our circle, so we can use this formula here to find what the equation for c is. So putting this in, so our centre is 7, 5, so it's going to be x subtract 7 squared plus y subtract 5 squared, and that's going to be equal to the radius squared, so it's the square root of 20 squared. So this implies that the equation for c is x subtract 7 squared plus y subtract 5 squared equals 20. In part C, it says that the line with equation 2x plus k, where k is not equal to 1, is also a tangent to our circle. Find k. So remember in part B we worked out that p is 3, 7, and we know that a is 7, 5. And we know that the tangent here is already 2x plus 1. And that's why we know that k isn't 1, because that would be the same as this one. It does mean that the tangent that we're trying to get is parallel to this one. So if we imagine what a tangent would look like parallel to that, it would have to be on the other side of the circle over here. So it's going to be a straight line that looks like this. So this is going to be our y equals 2x plus k. So I'm going to label this point that our tangent touches q. And we've got a clever trick here, is that because we know that p to a, the centre, is the radius, that journey there must be the same as that journey there. So if you remember from earlier, to go from p to a was down 2 and along 4. So we can do the same thing, go down 2 and along 4. So a is 7, 5. P was 3, 7. So q is going to be continuing that motion. So it's going to be 11, 3, along 4 and down 2. So we can actually use the sketch to find that. We don't need to do any equations. So we now know q. We know that the gradient of this line, m, is 2. So I'm going to use y minus y1 again equals mx minus x1. So y subtract 3 is going to be equal to 2x subtract 11. So y subtract 3 is going to be equal to 2x subtract 22. So y, our final answer, is going to be equal to 2x subtract 19. So that means here that k is equal to negative 19. That's our solution to question 6C.